My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 303. Before understanding this lecture, I request you to go through my previous lecture, that is lecture number 302. In this lecture, we will try to understand undersampling. Let me recall my previous lecture. We were discussing that how to work around imbalanced dataset problem or imbalanced dataset issue. Let's try to find beautiful solutions. My first solution is undersampling. What is this undersampling? We will try to understand. Let me try to explain undersampling. What is this basically? It is a solution for imbalanced data set. Imagine if my number of positive points is n1, let n1 is number of positive points and n2 is number of negative points. Let it be. That's what we assumed in my previous lecture. Let's say my n1 is, let me assume n1 is 100. What is n1? Basically n1 is positive point set. Let me assume n2 is 900. What is this n2? n2 is negative points. Let it be. Yes, let me assume like this. What undersampling does is, it says, let me assume this is my original data set dn. Let me assume this is my original data set dn. Let me write here also my data set dn. This data set dn is split into two sets. One is n1. n1 how many points? There are 100 positive points. 100 positive points. There is another partition n2. What is this n2? Let me assume this is 900 negative points. If you in the set notation, let me say this is 100. What is this 100 indicates? This indicates positive point set. Let me say this is 900. What it indicates? It indicates negative point set. Given this data set dn, what undersampling does is use the simple technique, that sampling trick, I can say, use the sampling trick to create data set dn dash. Let me say there is another, I am constructing a data set dn dash from data set dn. Let me say this is my dn dash. I will create a new data set. dn dash, where in which is the non-dominating class. Which is the non-dominating class? The positive class. Positive class means 100 points. Negative class means 900 points. In dn, which one is the non-dominating class? Positive class. There are how many points are there in non-dominating class? 100 points, isn't it? What about other partition? 900 negative points. I will copy all the 100 positive points into my dn dash. Just let me copy those 100 data points. Just I am copying this 100 data points of dn into dn dash using undersampling. Whichever have the fewer data points among that 900 data points, what I am doing, I am copying that fewer set, means a set which has less number of points. I am copying those elements into which data set? Into a data set dn dash. I will randomly sample 100 negative points. From this, I will pick only 100 negative points. Isn't it? Therefore, in your DN dash, you can have 100 positive points and 100 negative points. I will randomly sample 100 negative points. So the trick is, it is simple. So the trick is randomly sample N1 negative points from DN, isn't it? What is N1 here? 100. I am randomly sampling 100 negative points from DN and keeping that into DN dash. That's the idea here. N1 negative points from DN and place them in DN dash. We sample just 100 points of 900 points and put in DN dash. Now what happens in my DN dash? I have 100 points which are negative points, 100 points which are positive points. Now DN dash consists of equal number of points, equal number of positive points and negative points. This is perfect balanced set. Your DN dash is, I can say, it is perfect balanced set, isn't it? Yes. All of my machine learning modeling will work on DN dash instead of DN. From here onwards, after taking the sampling, my machine learning model works on DN dash instead of DN. So this is called undersampling. This mechanism, this is called, what is this? This is undersampling. This procedure is known as undersampling. So this is called undersampling because now we are going from 900. Just observe, from 900 we are going from 900 to 100. 200. We are picking only 100 positive points from 900 negative points, isn't it? We are going from 900 to 100. So whichever is the minority class, you keep as it is. Here, which one is minority class? Positive points class. I am keeping it as it is. I can say my DN. What is my DN? In DN, which one is minority class? This is minority class. This is minority class, isn't it? Positive point class is minority class. Which one is majority class? Negative point class. From this one, I am keeping this one is as it is. From this one, I am sampling. How many points I am sampling? I am sampling 100 points. That is N1 points. I am sampling. That's the trick. That's the trick. With undersampling, there is one problem. What is the problem with undersampling? There is a problem with undersampling. Originally, what is DN? Let me say, originally, your DN is, let me rewrite it. Let me say like this. Originally, your DN is having, how many points does it have? It is having 1000 points. This is original data set DN. In which, how many negative points? 900 negative points and 100 positive points. That's what we assumed. Now what about my DN dash? My DN dash, how many points does it have? It is having only 200 points, in which 100 positive points, 100 negative points, and one other set is 100 positive points, isn't it? This data set DN dash is much smaller than DN. I have thrown away 800 points, isn't it? I have thrown away 800 points, or not using 800 points here, and this data set DN dash is smaller because DN dash is much less than DN. I can say cardinality of my DN dash, number of points in DN dash, is smaller than number of points in DN. My model has smaller amount of data. Why? Because I am building model. My model will work on DN dash. Therefore, it has smaller amount of data. If I have used all these 800 points, that would have been great. But I am dumping all the 800 points because I don't have data. So throwing away. So let me write throwing away data, throwing away data is never good idea. Is never good idea. It should be avoided. I must say it should be avoided. It should be avoided, isn't it? It should be avoided. Imagine if I have this I am throwing away 800 points means what? What does it mean? 80% data I am throwing away, isn't it? 80% data is throwing away. If there is some work around this throwing away the data, there is serious problem. For example, if your majority class is 950, your minority class is 50, in that case what happens? You have to throw 90% data. It has got severity. Forget about this. Try to restrict to this one. In this case, as you are throwing away 80% of data, it is a serious problem. To overcome this problem, there is a technique known as oversampling. What is this oversampling? We will try to understand in my next lecture. Thank you very much.